a pleasure that Sir has been also awarded 2 times as a best faculty by Vidya Jyoti Institute of Technology and also by Indian Servers in 2019. So it's my privilege to welcome you, sir. And I request you start with your session on data science in engineering under the disruptive technologies in electronics and communications. Welcome you, sir, on behalf of department.
Thank you, ma'am. Thank you, Tulsi Prasad sir.
Thank you, sir.
And very good morning to all of you. I'll be start sharing my screen and just tell me, am I audible clearly?
Yes, sir. Yes, sir. You're audible.
You're audible, sir.
Okay. So let's do one thing. We all will stop our video and I'm starting sharing my screen itself. Okay. So hope my screen is clear.
Yeah. Yes, sir. Yes, sir. Clear, sir.
Okay. Thank you. So let me start. Tulsi Prasad sir, you have any video recording option at your side? You are doing any recording?
Yes, 1 minute, sir. Recording, sir. It started, sir.
Yeah. Thank you. So a very good morning to all of you on behalf of VJIT and EC department, as we all are a part of 6-day faculty development program on disruptive technologies in electronics and communications. I am here today morning to address all of you and share my experience in the field of basically data science in engineering. And the most important thing is that what we will do that data science is used in different what you can call fields, and we'll try to see one example in today's session and then see how best we can utilize it. So moving forward, this will be the simple agenda what I have kept for next 1 hour, the new age tools for data science. What skills we need to become a data scientist. I'll be covering this part very fast. Then once you go into the work field and you start either using, learning, or what you can call applying in your field, people will be looking for data sets. So I'll be speaking something about data sets. Google tools for data science will be very interesting because this session is that data science for engineers. So whatever the engineering field you are, maybe EC, mechanical, civil, electrical, computer science, artificial intelligence. If you want to apply the data science concept, the machine learning concept, there will be some few handy tools which will be pretty easy to utilize. Some of them before installing itself, you can start using. So we'll be exploring also some of the tools, not only just naming them. And finally, after seeing one example, specific application in image processing and data science, very simple one, then we'll conclude today's session. So moving forward, it's my duty because there will be some learners who are totally fresh, or I think the streaming is going on through YouTube also. So for that reason, it's my duty to update some of the basic fundamentals of data science. So data science is all about handling data in different way for different purposes, and hence it will be divided into some specific what you can call areas as well as its applications. So visualization is one of the most important part in data science that you'll be coming through across, and whenever you have huge amount of data and just a single computer screen may not be enough to showcase that data, that visualization becomes pretty interesting. Coming to the statistical modeling, where you apply some of the mathematical concepts of statistics, maths and statistics together, as well as the inbuilt statistical models are there, as for example, with Python, with R, and that becomes very handy to statistically analyze data, to do some prediction and all. And not only just you make the statistical model and active them, you can apply those statistical what you can call models in some computing field. Means you can generate some result out of it, you can do some prediction and all. There are different data technologies, data in research, data consulting, real world applications, as well as different scientific methods will be considered, because at the end it is a data science. So data science, of course, has taken what you can call, it has been evolved from the field of data. But as you know, data as well as other techniques of handling data in computer science is nothing new. We start with the basic definition of data, then databases, database management system, object-oriented database management system, relational database management system, object-oriented relational database management system. There are a quite good number of what you can call examples that we are already working in the field of data, and one we should not forget, which is data structures. So starting from trees, graphs to your single linked list, double linked list, and all what our students are doing, those things are pretty much there as a part of the journey of data. In the higher level of data science, it is the scientific and mathematical approach in the digital data world field, where you can apply some techniques and come out of unknown things. You can predict, you can analyze, you can visualize data. So overall, rather typing the definition, I'll try to show it with the form of some graphical representation. So what you can call, you acquire data, you have a lot of discussion, you find out the techniques and all. So data acquisition at the left side of my screen, as you can see, takes a longer path, that what kind of data need to be captured for this project. So that is very important. If you're taking about data science for engineers, that why you will be applying, where you will be applying, and from where your data inputs will be coming. That is very important. So if you are working into the IoT domain, then the sensors, what kind of sensors you have, what kind of data inputs they are giving, what are the name of this every data field, what will be the size of the data, is it ever-growing data or you got a static data to work with, there will be different issues. So data acquisition and then data preparation. Before you put it into some analysis or modeling, you need to prepare your data so that it become handy to use. So data cleaning transformation will be there. Then exploratory data analysis, where you can do all the visualization and other ideas. Even you can have some normal queries like SQL like queries you can apply along with pandas and all. Then data modeling, which is basically will be coming from machine learning part, which will be applied in different other fields. That's how the journey of what you can call data science happens. And most of you are aware, but just to thought to show you in a graphical representation. Now, as a data science for engineers, and what may be the engineering domain you want to make a career, that's how I look into the career building blocks of data science. You have maths and statistics, you should be good in programming and databases, domain knowledge and soft skills. That is very important, like which is the domain that you are going to apply your concepts. So domain knowledge is very important. As for example, being the EC members of this, what you can call, say a lot of us, we have joined around 90, 100 people today. So if many of you have the concept of the data in your domain, rather as for example, we can apply data science or data engineering in civil engineering, we can apply in medical science. But if you really don't have the domain knowledge, you might be very good in Python or R or any other, what you can call the new languages coming up like Julia, but it is not suggestible for anyone that without domain knowledge, you go ahead and jump into the data science in a field that which you are not aware of. So it is always better to start knowing your own areas, collecting the data, type of the data sets, apply the concepts and grow up. Slowly, once you master in one area, of course, you can expand your knowledge and ideas into the other areas also. So in case of the communication and visualization also will be a major role. So this is all together in the later stage. I'll request the organizers to share the slides with you. So anyone have, because I always feel whenever we get different kind of people in a discussion or FDP, it's not like that everyone just want to do research. Yes, there is some part they want to research. Someone might have been joined maybe from PG courses, or maybe they want to even planning for a career into data science, or maybe from a computer science domain, you want to make a career into the data science. Keeping that thing into the view, I am just considering it. So we'll move to the next slide. And in between, if any message is there, I'm not going into the message now. I'll be requesting the organizers, you can just stop me, and then if something is related to my discussion, you can ask me. So I'm not going to the message box at this moment. Then what one should know if you want to make a journey, if you want to apply data science in engineering. So data science in engineering will be done by human being. So I have tried to put in some few simple words where I see in this way. Know your own domain, which I was telling. So I'm bringing it from the previous discussion. Data science is playing with data, knowing from data and predicting with the data. That is very important. You need to play with the data. You need to understand this data is something really, it has something to say or not. Like if you have a huge collection of books, and basically if you go to someone's home and they have the personal collection or libraries, you'll find that this collection is basically where is their interest in. So if I'm totally interested in sports literature or journals, my 80 to 90% collection is sports literature or journal. If I'm totally into what you can call novels or something like I'm a Shakespeare favorite, then automatically for my favorite author, I have the whole collection of books. So data science is playing with the data in a sense that you should have understanding of the data of your domain. You need to keep on collecting, you need to downloading, and some of them you can create also for the work which others also doing, you are doing, and you can share it also. So first know the data formats, in what format you require. Even some people are not comfortable with a CSV format, comma separated values. And then if you have any Excel sheet, you can just save it as a .csv file and start working. You don't need to look for the special CSV file always. Moving ahead, you have data types that you need to understand. In different language, the type keeps on changing, as well as domain wise also. And they are sources and sub application fields in your domain. Their source, from where this data is coming. Is it a genuine? Can I do my what you can call study, my project, my research on that? Is it going to be helpful, or just I'm doing for the sake of doing? Finally, the data doesn't speak anything. That should not happen. And sub application fields in your domain. Being in EC electronics, IoT may be a domain. Digital signal processing, out of that image processing might be one of the domain where we'll see one small application today. Start analyzing the existing data with a goal. What can I do with this data? How can it will be helpful for one? Can I use it for some prediction or etc.? So list of questions should be there in your mind when you entered in the field of data science journey. So here comes slowly, as I told that this discussion will be more into like hands-on, where I should search, how I should work, rather than just a very bookish way of learning the thing in a syllabus-oriented way. I'm not going to do that in a very traditional way. I'm going to do this session in a very non-traditional way, and then try to come up to a work. So where to start, where I can get data set? That is one of the major question, and people keep on thinking, and then what you can call, they don't sometimes they stuck up, or they just feel that it's like available with the top scientist or researcher only. Can it be a field, it is only available in industry? No, nothing like that. Everything is now available. You are in a global village where every human being you can touch. Like if you want to reach to a data scientist, you want to discuss with them, you can go ahead and you can speak with them on LinkedIn, you can reach to them like that. So coming to this data search, if you can see datasetsearch.research.google.com, I have very clearly mentioned, you can make a note of it. This will also help you. Just normal Google search is something different, because you'll get different kind of content. So Google has created separate search engine for dataset search, and that's where you should search your data sets in your domain, or the domain you are interested or you want to learn. That is very important at the beginning of the work. Then we move to the Google research.google.tools/datasets. If you can see, little bit difference is there. Research.google/tools/datasets, and previous one dataset research.research.google. So there is a little bit different. I have done the searching also, and there is the little bit different in finding also. Maybe the backend algorithm, what they use is little bit different. So if as a part of tools and downloads here, if you go ahead and then you have the data sets in there, under these data sets, as you can see here, you'll be keep on getting the different kind of data sets that you can download and start using for your engineering domain or even non-engineering domain. Kaggle dataset, very popular as many of you, and this basically in this generation, I will talk about generation of people who are working in the data set. Generation not in the form of age I am trying to mean. In this generation means who are working in this generation in the field of data analytics, data science and all. So for this generation, data sets of Kaggle is nothing new. But if anyone, even one member is also there in this session, for him or her, it will be useful that you can go to Kaggle, make your own account. Kaggle also conducts a lot of hackathons, which you can start participating. It has also what you can call tutorials to learn and earn certificate free of cost, which are commendable. So going to the new one. It's not, as I told at the very beginning, that it's not just like that. You can also to become a data scientist or data architect or data analyst. Most important, actually, any field. If you want to become an actor, you should have the passion and liking for it acting. If you want to become a sports person, you should have liking for sports. You should give time for it. You should be understanding what is fitness about. You should be fitness freak. You should be the early riser going to field and make yourself ready for that field. If you want to be in chess, you need to play a lot of chess. So this love for data is also, you can show Google has given one more platform for you, crowdsource.google.com, where you can contribute as a data architect, as a data scientist. Google has different, like, image level verification is there. You can see the image caption, handwriting recognition. You can contribute with your handwriting and then some what you can call ideas over it. That will be helping you to globally connected, and you can earn a badge from Google, and you can start adding. If the people, even I'm sure, pretty sure some of the students also join with us today on some YouTube platform and all. So that badges you can even display on your LinkedIn, on your what you can call CV, and you can, for others research and all, those badges will be giving you confidence that yes, I have contributed 1000 data or level verification, and then you'll be getting some other benefit out of it also. Now coming to the little bit deep into the other kind of tools that Google, there are so many other tools that I'll be coming. I will show a research slide which took almost 10 years for me to make and give you some direction that what are the different kind of tools. But today specifically, I am what you can call concentrate in the Google field, the Google supporting tools in the field of machine learning and data science, so that we can what you can call leverage at least one field, and slowly, it's not like that Microsoft is not doing or Amazon is not doing. You have a lot of tools over AWS, Amazon Cloud. You have a lot of tool on Azure, and you can utilize them. Every platform as well as technology being with the top companies or giants brings some data science and machine learning tool for you. Anyhow, this ML kit, then fairness indicator, then you have TensorFlow, you have Colaboratory. That's why I kept it in center. We'll be using the Google Colab, and we'll show you a little bit example over that. Google open sources. So there are a lot of tools that where you can learn, you can contribute, and also there are tutorials that you can go through to become a future data architect, data analyst, or data scientist. Slowly, we'll be moving forward a little bit on hands-on, and you can do it later also, but just to give you the confidence that if some of you have not yet explored this field, you should explore them, and then that will give you a lot of confidence that already you are in this journey. So don't wait for a wonder streak or some magic is going to be done by Harry Potter if you want to become a data scientist or the data architect. The journey is all yours. Even what you can call local school, like you go to some centers and learn, nothing wrong. But if you are already in the field of, from the field of programming, if you are really aware of what you can call data structures, database management system, you are aware of digital signal processing. So what may be the engineering field you are, and every engineering field has a C and data structure. Whenever we have passed out in our BTech or MTech, we have come through some programming languages. We have handled data in different way. Keep that confident with you and start this journey. What I will trying to show little bit today as a part of it. So collab is where you can collaboration. Google collaborate for your data science and machine learning code that you can write at uh, just after logging in your Gmail or Google account. So that this is how it looks like. Once you have your Gmail account, you can go to the next tab and then start opening. Or after logging into your Gmail or Google account, this is how you can very easily go to the Google Colab, the drive.google.com, go to the drive.google.com, and from there you have new, and under new, if you go to more, at the last one, more, there will be a pop-up menu. From there, another pop-up menu will come, Google Collaboratory. See the last one, right side, last corner, bottom corner of the screen, and you have Google Collaboratory. If you click there, it takes you to the Google Collaboratory for work. And this is where it looks like your, what you can call, we can call it, it's a Jupyter on something like, it's a Jupyter notebook environment to work for, which basically you install in your machine and start working. So for the beginners, as well as sometimes we keep on thinking about tool and the environment we'll be working with, but they are very much correlated when we work on them. So that's, we'll have some little bit of hands-on, log into your Gmail account or Google account, another tab open, Google Colab environment, understand the pass cell and pass text on Colab. These are the two specific options basically will be very given to you. And I'll come back to this slide. First, I'll go to Google Colab and then we'll come back and explaining the next part of it. So let me share my Google Colab environment so that it should be clear and visible to all of you. So this is the Google Colab environment. You can move in from your Gmail or Google account, and you can see that if you see the right top corner, it's through my Google account. So you can see my mail ID is pretty clear. So you need to log in, otherwise you cannot use it. And once it is all fine, it's like where you start working on your Python code, you can directly start writing. So going ahead, already have seen. So as you know, in this any kind of Python environment, once you have, you can just go ahead and start what you can call working. I'll just try to make the screen a little bigger so that you can see. So let us consider this. And then we go ahead and you can click here. That is one option, run cell, control enter, that will be executing, or you can also do shift enter. So you start getting the result then and then working with that. As I told, so you have a code, insert code cell below, and it has also the shortcuts. You can see there. It also has the text, add text cell, which is also very important because this new environments like Google Colab or Jupyter Notebook is not just writing Python code and doing code. We always feel, or some of us who wants to make a journey in the field of software engineering or software developer, remember that becoming a data scientist, you are not deviating from the journey of becoming a software engineer. A data scientist also a software engineer only. It's a specialized field. A data architect is also a software engineer. It's just a special field. So you are not just supposed to, or not always writing the code and run it. You need to demonstrate your activity and actions. You need to go ahead and also project your project work. And in that case, this kind of tool will become pretty easy. So you can also go ahead and give it faculty development program of 25th June. You can give it some name and it will be saved and you can start working on. Now I'll be looking at little bit with the text because anyhow we'll come back to the coding part later. So we'll be going ahead for the text part and see what happens in this text one. In this text itself, there are different options that you can work with. So as for example, this text totally works with that kind of concept which is called as markdown language. As you know, markup language, hypertext markup language already we are aware of. Here it is markdown language. The markdown language help us to create a different kind of format to showcase our work and activities. And for that reason, we'll be going ahead and trying to do something. As for example, if I want to do some, what you can call heading. So, and we can do and see the right side already it has come. Before I execute it, the right side it is showing a preview here. That is the advantage of working with such kind of tool. Now heading, so or you can go back and you can start thinking of my project work, because that's how the new age people will be working to project their work. Not only just for Corona, in the total digital world, it works like what you can call. So my project, shift enter. So shift enter, it becomes a heading for you. You can go ahead and add some other. So it's a image processing work that we want to do. Shift enter. See, now here is the difference. So as I have done this work in a code cell, it will not work. So you're not supposed to do the editing, text editing part in the code cell. What to do? You can just delete it and go ahead. So text cell only will be, so that's the difference. I want to show you the code cell and the text cell. You can only work on markdown language using the code, text cell itself. The code cell is for writing Python code. So let us go ahead and give some title to each image processing project kind of thing. So we get slowly based upon that, you can start getting. You can also add the simple text like this project work is a part of my PhD thesis. So you can start, and later stage we'll be giving a demonstration over it through this tool. Unnecessary things as and when required, you can what you can call omit them. So the Jupyter notebook is also equally working very pretty well for your work that you want to demonstrate. And we can even what you can call, interestingly, the mathematical expressions are taken very nicely here. The mathematical expressions are very nicely. Let us take one more example of a mathematical, that I need to show some mathematical expression and then I need to write something out of it. Then how come I can do? So going back to the code cell, and you can double click if you are coming out of the cell, double click. And here is some mathematical expression. You need to just go give it with a dollar symbol at the very beginning and dollar symbol at the end. You see right side. So this is the advantage of working with the tool when you have big mathematical expressions. The markdown language helps you to mathematical, and you can execute it. Shift enter, as I told. Shift enter, you just press here. Shift enter will help you that now it has become a normal text. See, this is how you can create your digital presentation for your PhD work, for your thesis work, for even you can make your CV, nothing wrong. And then you can showcase some of the technical things in that, and you can share with different organizations, your team members, or as we are using, I'll be using one of the Jupyter notebook for presentation as well as a coding purpose. After that, we can also utilize what you can call some of the order list and unordered list for it, order list and unordered list. By that, I want to mean that, and coming back here, coming back here, we can also add the comments. We can add comment, and this is a comment. So my math expression or my formula is something like that, and you can keep the comment. So right side is the comment is there. So it becomes so handy for a what you can call other people whom will be collaborating you. So collaborate in your project, collaborate in your technology. That's why it is collab. And right side is what is the what you can comment. So any other people, when you jointly work in a project, or some other people you have just shared your Jupyter notebook, it becomes pretty handy to work. So a data scientist uh, will be a perfect data scientist provided he has the perfect tools to handle data. And data is not just in the CSV form, Excel sheet and all. So your mathematical formulas will matter. How do you display them and explain them will matter. From where the data is coming will be. Every sector need to be taken care of. I don't know, Rohit has raised a hand. Rohit, you can keep your question in the message box. We'll get back because I just want to finish some of the specific thing before we move ahead. Personal queries we can take later. And this is how, what you can call, and always it will come back to the code cell where you can start writing your code. So we'll be moving ahead and stopping this sharing now and going back to my presentation where I was. And before that, let me just check if there are few. I'll just have a look if something very specific is there. Most of them. Good morning. And good morning to all of you who have joined with us a little bit late. Yes, we'll try to share this video or the presentation. Even I will also be sharing the total work that I am going to show. What is the Jupyter notebook file that we'll be sharing with you. Uh, Thank you for commenting. It's very interesting session today. Thank you, all of you. And I'm moving forward and sharing where I have stopped, and let's see where I was. So coming back now the journey is little bit clear. When I know where will be my data sets, when I know that how I am going to jump into my domain of engineering, and then what are the tools I require for collecting the data sets for work, and I have not installed anything. That is interesting. And I feel whoever in the field of data science journey or machine learning, they are aware of Python, are so many courses you have joined, but how to up and bring them together is what I am trying today. I will not spend much time on this slide, but this is very common in Google also. I have not created it, so no credit I am taking. You can see the different kind of tools that whatever you can see here, you have machine learning and AI application tools. So they have been named with, you have Microsoft machine learning tool, ML, H2O is a tool, I think over AWS. You have the TensorFlow, you can see deep learning tools. You have languages like C#, Julia, R, Python, JavaScript. We have the development tools, data platform, and ingestion tools, bringing them together, something like Spark and data exploration tool. Don't be panic. When you did even BTech and MTech also, my dear friends, a BTech has almost 60 subjects, 50 to 60 subjects are there in BTech. So the first day of first year engineering, when we joined or our students joined, no one thought after 4 years you'll be finishing 50 subjects. So we do. But how come we could make it? Because there were 8 semesters, because there were predefined syllabus, because there were teachers or mentor to guide, because there is the governing body like university to tell what will be taught as a part of it. So like this also, you can follow one institution, consider that is the university. So that will be my suggestion. As Google has kept most of the tools free, I feel Google can be a very good university for us. And from there, you choose one development tool, Jupyter, and Jupyter on Colab. I have told you, if I go to the right itself or top, you can choose R, Python, and in futures, Julia from here. Deep learning tools, you can choose one out of TensorFlow here. If you're coming here, Microsoft ML, some part is free. You can choose out of here. Going ahead here, Weka is pretty much open. You can choose one from here. Coming here, Spark will be available from Apache. You see, so we have made a total cycle out of it, which is possible. So make under that university, make a plan and see that what are the things you don't require much of the installation, and you can go ahead. So as a Google login ID, you get so many options, and most of them you can use directly on the Colab. I'll be suggesting this journey for you. This is the research as I was talking about, dear teaching fraternity and the students who have joined with us. I've done extensive research to make this slide only, that what are the different Python packages, what are the other tools for not only for data science, artificial intelligence, machine learning, deep learning, and data science. These are the fields. And if anyone's still not clear or someone who have joined late with us, I'll just take a minute time to make it pretty clear. What we do here is that in case of artificial intelligence, you make the machine to work intelligently through code. In case of machine learning, you require the data, and then machine learns from data and do some work. In case of deep learning, the machine learning algorithms or techniques little bit fail when you have huge amount of data and do something out of it. The deep learning becomes very handy where it uses the neural networks in different, what you can call layers, and make your task much easier. And finally, in the field of data science, where we apply the concept of all these three fields and scientifically handle data to take decisions, make predictions, or analyzing. We require the algorithms, tools, and applications to do that. So this will be shared with you, because if I want to explain this, it will take almost 3-4 days. So you have other tools, you have supervised and unsupervised machine learning algorithms, you have the reinforcement algorithms, and we also have the applications where you can apply. So I'm moving forward and see that the organizer shared this slide with you. This is also available on my LinkedIn account. Now we'll be going ahead with working with my local machine, because that's also required. And in working with the local machine is that same Jupyter platform we'll be working with. And we'll see that once you install your Python, you should also installing your Anaconda. And all these red T marks, you can see the red marks, tick marks. These red tick marks will tell you what are the essential things you'll get. But the last tick mark, this means if you have just Jupyter, it will be coming along with Anaconda. But if you want to work with TensorFlow, you need to separately install it. Any of these packages, as you are aware, you can install them through the command prompt of what you can call your Python installation or Anaconda prompt, or directly you can open a Jupyter notebook on Anaconda and you can go ahead with installation there. All the informations are available on site. So this is my clip of my start screen, where in my system these things are already installed, because I cannot show this installation as a part of FDP. It will take a lot of time. So let's code. This will be the last part of this. We are left out with 12 minutes to 15 minutes. Machine learning in data science. So as you know, supervised learning, as you have just seen, supervised and unsupervised learning. Out of it, I just choose a K-means clustering, which is unsupervised learning, because most of the people you might have been joined in many sessions, they go ahead with supervised learning and you do something there like regression and all. I'll be choosing a K-means clustering, and we'll be working with the Jupyter on Anaconda platform. And as is the EC department, to give a thanks to EC department as a part of color image compression, as a part of DSP, digital signal processing, image and speech. I'll be working a small work on color image processing using K-means clustering. And I will be not teaching any code now, so we'll be requesting you to not to ask the coding related question today, because it's not possible in 12 minutes that I can teach you code. I'll be showing you the flow of working, and believe me, all the code available in any book or website or tutorial or Coursera, code is not at all an issue. It is the way you are trying to work and what is the approach you will follow. So I will not come to this slide now. The thank you, sir. This is the last one, but we'll go to the working environment to work and just stopping the sharing here, and we'll see if some questions uh, if any other thing is there for you. Nice session, nice presentation. Thank you all. Yeah, both are same. The difference between there's some question I got is that Jupyter in Anaconda Navigator, and of course once you go ahead and work with Jupyter on Google Colab platform, you get the support of GPU and TPU, whereas in your local machine you work on CPU. So in many cases, or if you are doing some course already in Coursera, you are aware that you are going to what you can call work with the environment which is in Colab. There will be no other Colab something else there. Okay, so I'll be moving. Just give me a second time. So we'll be sharing my Jupyter notebook. Yes, here it is. So already I have started my Anaconda platform and then chosen Jupyter. As you know, whoever you are working, you have all your uh, Jupyter notebook files. So I have specially prepared one, what you can call project work for this today's work. I'm sure that my screen is visible to all of you. It shows the Department of EC FDP 25th June 2020.
Yes, sir.
Yeah, thank you. So intentionally I have made it, and as I told, everyone speaks on some coding as well as some regression and all those things. I don't find that something new is left out there. What I see is that missing is that people cannot present their work. Even today in this generation, let be I am presenting my MTech thesis, PhD thesis, or my postdoctoral, or I am looking for a project funding, or the many students have joined today that they will be taking the interviews online these days. When we ask them to share your credentials, this just share the CV. No, if you're joining for a software engineering, what you can call job, a data science, data analyst job, your work should be pretty ready, and you should ask the interviewer online, it's a little Zoom, can I share my screen, sir? You should have the eagerness to show that, and this is how it is clearing. So that shows that we are in this FDP today, and everything is what you can call already ready to what, because typing a lot of time, and we have chosen a K means clustering to do that. And we're just telling for the, if anyone is new learner is there, in case of supervised learning, we call it as a classification, that where you have predefined classes, and then you what you can call divide the data into different classes. So class A, B, C, D already you have, and you take the data input and already sort them. You sort or classify the data in the predefined or level data sets. That becomes pretty easy. That comes under supervised learning. In unsupervised learning, what we do in unsupervised learning, basically we go ahead and we create clusters, and these clusters are from similar kind of data sets. Similar kind of data will be in cluster 1, cluster 2, cluster 3, and cluster 4. And that how unsupervised learning work, which is a major concept in machine learning, and we apply into the field of data science. And today in a specific field, so from machine learning, I have chosen unsupervised learning. From unsupervised learning, I have chosen one specific algorithm, which is K means clustering. And also I'm applying it, as it is the today's session of FD is that applying data science in engineering. So I have chosen DSP, image processing, and then K means clustering is going to apply on a specific technique is compression. So that was I was also trying to say at the very beginning is that you should be pretty clear and give a proper what you can call visibility of your work wherever you discuss. let it be we as the professor, once we discuss to the students, or the students will be discussing with us, or we'll be giving a demonstration for some funding or some collaboration with any companies across the globe, being the professors. That is how it looks. It should look, I feel so. Now, K-means clustering is an unsupervised machine learning algorithm in contrast to traditional supervised machine learning algorithms. K-means attempts to classify data without having first been trained with level data. So you are not training, you're not giving any training to your module or model. You're just going ahead and applying the concept of K-means. Once the algorithm has been run and the groups are defined, and new data can be easily assigned to the most relevant group. So it will be joining the most relevant cluster. What are the areas you can use K-means clustering? The real world application of K-means clustering are customer profiling, what kind of A category customer, B category, C category customer, customer who likes blue jeans, customer who likes Maruti car, like that. You can customer profiling, you can do market segmentation, you can do computer vision out of it. Search engine can be working on these areas. Astronomy can be done. So we are not going deep as a part of it. Now understanding basic K means, and then we'll apply it. We need to import these libraries in the step 1. And that's what I told, how handy it becomes to work with this kind of environment. So as I'm going to give the demonstration, and just you think you are going to give the demonstration, and just copy it. And in this specific space, I just add insert cell below. I just do a insert cell below. I'll make little bigger my screen. It should be enough, I feel. Now what I do is that I just copy paste everything here, and just I do shift enter. So that is the advantage of properly using those tools, being you a data scientist, not you just know Python, you just know R. There are many people who maybe the programming language is better than us. It is the journey of who can demonstrate and can tell a story in a much better way, that we need to remember. So application of data science in engineering is not only just applying a programming language, it's need to tell me an end-to-end story with a proper planning. Now coming to the next part, generating our own data using the make blobs function from the sklearn.datasets. And this is the step 2. And as I told, I'm not going to explain any code here because these codes are very popular and you will get it in any Python tutorial. So go ahead and understand what about that. So I will not taking any queries basically on coding today. It's not possible also. So I just again Control C and see same procedure I'll keep on doing and demonstrate. And of course, for your case, like interviews, all those things, you need to explain each one of these things, which I'm not going to do. So this is the first way how K-means work, and it helps me to demonstrate you. It's a randomly generated, what you can call data sets, and we can see the center says that there are 4 clusters, and in these 4 cluster data has been, so randomly data sets have been generated and with the help of make blobs, and you can see. And if you are coming from the database management system, blob, CLOB, these are very common. That's why I told, suddenly you cannot jump into the database, data science journey, provided you are not aware of the journey of data, what you can call data structures, database management system, and then you are taking yourself ahead. So this is how the K-means clustering work, taking this input inside at our step 4. Now we can also do that categorizing the data using the optimum number of cluster. That is the, what you can call, we can see what is the data we have already created. So once again, I am not into the data sets that what we have done. So I'm taking this part once again, Control C, and I take one more cell, Control V, and now I do a shift enter, and you see now the center, that is the most important thing in K-means, the center points of this each cluster surrounding which the data get, what you can call, accumulated. So the even 4 center points are also, there are four centers, which is pretty clear, that is also created. So that's how the demonstration go ahead, and your understanding itself of K means clustering. Coming to our small project that we'll be demonstrating in last 2 minutes. K means for color compression. One interesting application of clustering is in color compression within images. Let's, for example, imagine you have an image with millions of colors. That happens actually. And today with the digital cameras and smartphones, the color are captured at micro and granular level itself. So in most images, a large number of the colors will be unused. That means if you remove that color also, your image is not going to change much. And that is where color compression happens. That means if some unused colors are there, which is not making much effect in the image, we can club them with the popular existing colors. So automatically my color image will be compressed. And many of the pixels in the image will have similar or even identical colors. So club them together. There will be many colors which are just existing, but not properly used in the image. We'll merge those colors with the most nearest common color, that is K nearest is coming into the picture, and will reduce the size. So this is the step one of our project work. And we'll be in need of installation of Pillow package from Python to work, because Python image library is PIL earlier, now it is Pillow. Now it is Pillow. So you need to install it if you want to work in the field of image processing, which I have already done. So I'm not going to do this process now. The commands are pretty much available on site. Conda install -c anaconda pillow, and just execute the cell. Your Pillow installation will be done. I am coming and to the step 2, importing the required packages for this project. So we'll be going ahead, and as I always do, I'll be adding one cell here and going ahead and Control V, Shift Enter. So all my required packages have come here. Step 3 is loading the China.jpg from Skikit learn and display it. Intentionally it's taken this part because these days we are discussing a lot about China, but it is not always bad. Today we'll use the China image for a good purpose, and that is image compression purpose. So loading the China.jpg image, which is a part of the Skikit learn and display it. So from Skikit learn dataset import load.sample image. So it is an inbuilt one. You no need to take any what you can call attention for this. We'll be doing this process now. Now the image itself is stored in a 3-dimensional array of size once you do this part of coding. And this is now I'm going to do for you. So I need to add one more cell, and I go ahead and I just Shift Enter. I do Shift Enter. So now I just check here why it is giving scalar data set. It was pretty much there. So what I do is that I will not go to resolve it at this moment, and I'll be showing you the task which is already there with me. Just give me a second time. So that's where it becomes handy. Sometimes you don't know when it is stuck because the same code. So what we do is that I think the image is clear to all of you. Is the image clear? China.jpg. Organizers, is my screen visible?
Yes, sir. It's visible, sir.
Yeah. So the image has been loaded with the same code. So I'm continuing from here, and then you get the shape of it. You get the shape of it as the next level. So the China.shape will be giving you the shape of the image. And then we also go ahead and we do this specific part, that we do the reshaping of the image. Now, reshaping of the imaging will be helping us to understand the image where you have the more number of pixels and size, so that it becomes for maximum number of pixels, we can improve the efficiency, and that we go ahead. And finally, the code to visualize. You have the code to visualize this, what you can call outcome of it. So we'll have this code to visualize, and that will show us basically that what is the input color space and 16 million possible colors. If you bring them together, and you can make the scatter plot and you can plot them, and that's how it looks like. That variation one is that, as you know, in case of what you can call blue and green and red and green, we have taken these two specific fields to give a what you can call demonstration. And finally, going ahead, we can even do the next part where we reduce these 16 million colors to 16 colors. Now let's reduce these 16 million colors. The 16 million colors will be just reducing into 16 colors, and using a k-means clustering across the pixel space. Because we are dealing with a very large data set, we'll use the mini batch k-means technique, and there will be some specific code to overcome the what you can call warning itself. And then we'll go ahead and applying this what you can call code. And finally, we'll see that this code will be help us to regenerate the image after compression. If you see the left side image and the right side image, so this is the original image, and this is only the image which is with 16 colors. See the type of reduction it happens. Yes, in every image compression, you will be losing some what you can call quality of the image, and that is very common. Who are working in the field of image what you can call processing and compression, we are aware of. So this is how basically we do the task in case of what you can call applying a k-means clustering algorithm for image compression. And I'll be stopping sharing the screen here, because I want to always be within time. Many people have taken out their own time and joined with us. I thanks the organizer. Am I audible now?
Yes, sir. Audible, sir.
Yeah. So that sometime I think audio when this is nothing in my hand, might be a network issue.
Okay. Okay, sir.
So thanks the organizers for giving me this opportunity. Maybe one or two, anyone either from the organizer side or any of the what you can call.
Hello, sir. Voice is breaking, sir. Sir, from your side, voice is breaking.
Am I audible now?
Okay, sir, audible, but now and then your voice is breaking, sir. Just I unmuted everyone, sir. If anybody is interested, they can unmute themselves and they can ask questions. Speaker can answer your questions. I request all the participants. I unmuted all. You can unmute yourself and you can ask any question.
Okay, if there is no question, sir, we can.
Okay, sir.
Yeah, sir, I'm here. Thank you, Go sir, for your wonderful presentation and making a mark on artificial intelligence and data science engineering, and focusing on all points. And whatever the time you got, you have enlightened everything. And it's very, I hope it's very useful for the participants, and may they bring up with more advances in that, and have an initiation to learn more about data sciences. Thank you, sir. Thank you for the session. From on behalf of EC department, I thank participants and speaker sir for joining us for
Tarigini ma'am?
Yes, sir. I'm
okay,
here,
yeah.
sir.
Okay.
If anyone wants to ask questions to speaker sir, they are invited to ask.
Thank you all. So with your permission,
thank you, sir.
Keep the session.
Yes, sir. Yes, sir. Thank you,
Yes,
sir.
sir.
Thank you for coming and.
Thank you so much, sir.
Thank you. Thank to both of you and the EC department also.
Yeah, thank you, sir. Thank you. లింక్ పెట్టేశారా సార్?
నేను పెడుతున్నా మేడం. సార్ ఇంకా క్వశ్చన్స్ ఎవరు లేదు, ఏం చేద్దాం?
పర్లేదు సార్, ఇంకా ఫీడ్బ్యాక్ లింక్ పంపించేద్దాం. ఎవరు అడగలేదు కదా. అదే అదే. ఇప్పుడు చాట్ బాక్స్ లోనే పెడతారా సార్, వాట్సాప్ కి పంపిస్తారా?
చాట్ బాక్స్ లో పెడతాం, వాట్సాప్ పంపించేద్దాం మేడం. ఇందులో ఫార్మాలిటీ పెడదాం ఇందులో.
ఓకే ఓకే ఓకే. We'll wait for 10 more minutes so that they can fill and submit. No.
ఫీడ్బ్యాక్ లింక్ పెట్టాం మేడం. తరగని మేడం, తరగని మేడం, ఆర్ యు దేర్? తరగని మేడం.
Sir, unmute available. Yes, I request participants to fill the feedback form. Sir, we'll wait for a few minutes. Participants, feedback form is available in the chat box.
It's not accepting, madam.
Okay, now try it.
Yes, sir. Thank you.
Now again, once again, you just try. Are you able to fill the forms, participants? Some are showing that your link is not available. వస్తుందంట సార్.
సో ఓపెనింగ్ మేడం, ఈవెన్ యూట్యూబ్ లో ఓపెన్ అవుతుంది.
You go back and refresh and click upon link and retry to fill the form. Sir, మళ్ళీ ఇంకోసారి పంపించండి సార్ ఫామ్. Yeah, form is available once again. Form is available once again. Participants can click on to the form and fill up the details.
It's working, ma'am. Just they ask them to try once or twice.
Yeah. Yeah. Now they are able to fill, sir.
Yes, ma'am. Yes, ma'am.
Okay. And we also have afternoon session at 4 o'clock by Dr. Vish Kumar sir. We meet at 4 o'clock.
Hello, ma'am.
Hello.
Hello.
Connect in VLSL.
Hello, ma'am.
Yeah,
Yes,
ma'am.
ma'am.
Ma'am, actually, I got one doubt just now, madam. So, can you connect to sir, madam? Is it possible now?
He is out of meeting, ma'am. Okay. Later, if you send any question, I'll actually take it forward to sir and let you know, ma'am.
Sir, can you please send sir mail ID or sir details,
Okay,
sir?
I'll send, ma'am. I'll send later.
Okay, thank you, sir. It's a wonderful session, sir. Thank you.
Thank you, ma'am. Thank you for your participation. ఫీడ్బ్యాక్ అందులో పెట్టేస్తాం మేడం.
ఓకే సార్.
ఇందులో పెట్టేద్దామా, వాట్సాప్ లో పెట్టేద్దామా?
వాట్సాప్ లో పెట్టేసాను సార్.
ఎందుకంటే వాట్సాప్ లో పెడితే అందరూ పెద్ద ఇబ్బంది అయిపోతుంది మేడం. కీప్ ఆన్ ఆస్కింగ్ అదర్ థింగ్స్, పర్సనలైజ్ దే ఆర్ ఆస్కింగ్.
Okay, sir. It is better to keep here only then.
they don't have interest, and later they'll come and ask. So we'll wait for some time, ma'am. Later, I'll put that also in WhatsApp groups.
Okay, sir. So those who are there in participation list, try to fill the form as soon as possible. Yeah, in afternoon, like evening, we have 4 to 5. Dr. Giri sir, Associate Professor of EC Department, will be dealing with nano interconnects in VLSI. Soon we'll meet at 4 p.m. So may I leave, sir?
Yes, ma'am. You can leave, ma'am.
Yes, ma'am.
Thank you, ma'am.
Thank you,
ma'am.
sir. Thank you, sir.
So we meet
Thank you.
again just 10 minutes before 4 o'clock.
Yes, sir. Yes, sir. Okay, sir. Thank you, sir. Good day.